In this lesson, we are going to talk about domain and range. Now, in the previous lesson, we introduced the idea of what a function is. So, like if I gave you the graph, you would know it's a function if it passes the vertical line test. So, every time we learn a new function, and that's going to happen pretty often in this course, every time we learn a new function, we are going to be talking about the domain and the range. So what is domain? What is range? Before we introduce that idea, I want to quickly go over the number systems that you should know about. You learned them in grade 9. So you know what, let's just go over them really quickly. So you have the natural numbers, they're the numbers used for counting and ordering. So when I first taught my kids I taught my kids about numbers, I started with natural numbers. And then I introduced the number 0, which goes from natural numbers to whole numbers. So what are whole numbers? All natural numbers and 0. Let's use the word 0 and 0. What about integers? Integers, well, we're going to we're basically including more and more numbers now. So the situation is getting a little more complicated. So I actually taught my son about negative numbers when he was in JK, and he understood the idea. I think the easiest way to do that was basically playing a game with him and making him lose. So anyways, all natural numbers and their opposites. So what are opposites? Once again, that's something you learn in grade 9. So like 1 and negative 1 are opposites. So all natural numbers and their opposites. And of course, 0. So that's integer. Now the next number set is rational numbers. So you don't have to work with whole numbers. You don't have to work with 5 or 6 or like you can work with a part of a number. Okay, so or a fraction of a number. Sorry, that's what I meant. So rational numbers can be expressed as a ratio of 2 integers. So now let's say 5 over 2 or negative 4 over 7. Let's go with that. And irrational numbers cannot be expressed as the ratio of 2 integers. So we have root 7, of course, we have pi. Now, real numbers are what we really want to get after, okay? So real numbers are all the numbers that you know of, okay? So from high school math, these are the numbers we work with. Natural numbers, whole numbers, integers, rational numbers, irrational numbers, and all these are part of the real number system. So like irrational number, you're a real number. If you're a rational number, you're a real number. If you are an integer, you're still a real number, okay? And this is what we really want to get after. When we state domain and range, for the most part, we're working with real numbers. Okay, but it's important to see how we built up to real numbers. You start with natural numbers, then whole numbers, then integers, then rational numbers, then irrational numbers, and finally you have real numbers. And if you look, there are some symbols that represents the different number systems, like a double stroke N for natural numbers, okay? You have a double stroke W, double stroke Z, double stroke Q for quotient, because it's a ratio of 2 integers, and then irrational number. Now here, this one, we don't all agree upon the symbol. It's not universal, but we put Q prime because rational numbers and irrational numbers, they're complements, because if you put them together, all the rational numbers and all the irrational numbers, you get the real numbers. But anyways, like I said, the big focus here is on real numbers, okay? So what is a real number? That's what we really have to get after. And unless you took some extra math classes somewhere else, then you've probably been working with predominantly just real numbers, okay? All right, so now I think we're ready for domain and range. So what is the meaning of domain? What is the meaning of range? So let's read the definition here. Domain, the set of all values of the independent variable in a relation. Okay, so what are all the possible values of the independent variable? Okay, and usually when we talk about independent variable, we use the variable x. So you can think of when you ask yourself what's a domain, you can ask yourself what are all the possible values for x. Okay, whereas range, it's a set of all possible values for the dependent variable in a relation. So what are all the possible values for y? That's what I think of when I'm asked of the range. So domain, what are all the possible values for x? And for the range, what are all the possible values for y? So we're going to work through the different representations just like last time. So I can give you a set of points, for example. Okay, so if this is the representation we give you for the relation, in fact, this relation is a function. But anyways, if this is the representation we give you, then you can establish a domain and you can establish a range. So simply ask yourself, what are all the possible values for independent variable? So in this case, I'm going to write them in ascending order. So -5, -3, -2, 5, and 6. And what about the possible values for a dependent variable? We can ascending order. So -8, 3, 4, 6, 7. So if those are all if those 5 numbers are the possible values for independent variable, that makes up your domain. And of course, these 5 numbers, the possible values for a dependent variable, that makes up the range. All right, so another representation we might be given is a table of values. So no problem, same question we ask ourselves. What are all the different possible values for the independent variable? So we have 9, because shoe size is our independent variable and height is our dependent variable. So 9, 10, 11, and 11 and a half. Okay, what about the dependent variable? All the possible values we're looking at: 158, 164, 167, 170, 172, 173, 175. All right, so guess what? I can tell you what the domain is. So the 4 possible values for the domain are 9, 10, 11, 11.5. For the range, 158, 164, 167, 170, 172, 173, 175. You don't have to state them in ascending order, but as a teacher, when I'm marking a test, it really helps, okay? So I always recommend the students to write them in order for me. Okay, so we just stated the domain and range when we're given a set of points and we're given a table of values. Unfortunately, for most of the examples in this course, you're probably not given a set of points and you're probably not given a table of values. What you're most likely given is either a graph or an equation. So, but the goal is still the same. If I give you a graph, you want to come up with the domain and range. If I give you an equation, still domain and range. So if we give you an equation, okay, I'm hoping you'll see in the next few examples, it's a good idea to give yourself a graph because you can visualize all the possible values for x, and you can visualize all the possible values for y. So when possible, okay, if you're given an equation, when possible, give yourself the graph of the relation, okay? Now I said when possible because unfortunately there will be times where you don't know how to graph it, okay? Or you might not know how to graph it yet because you only know how to graph lines, parabolas, and circles. And if it's not a line, parabola, or circle, you don't know how to graph it. Okay, so let's see. We have the equation y equals 2x minus 5, and you could state the domain and range just equation, but like I said, it really helps if you have the graph. Okay, so I'm going to graph it. I give ourselves a nice scale here. 1, 2, 3, 4, 5. 1, 2, 1, 2, 1, 2. So the slope is 2 up and 1 over because, sorry, the slope is 2, so it's rise of 2 and a run of 1. All right, you can label it. There you go. So y equals 2x minus 5. So hopefully now that you see the graph of y equals 2x minus 5, you can ask yourself, what are the possible values for x? And what are the possible values for y? So you see these arrowheads, okay? That means this line extends all the way to the right, like goes right forever and goes left forever. And also goes up forever and goes down forever. So really, I'm hoping to say that there are no restrictions for x nor y, okay? X and y could be anything. So since there are no restrictions, this is how you state the domain and range. X can be the set, so these brace brackets means the set of all x such that, so this vertical bar is such that, the set of all x such that x is an element of real numbers. So element of basically means like you're part of that family, you're part of the real number system, okay? Now, this is very different from what we did before because, that's what we have to do because in the previous examples, whether you're given a table or a set of points, you could just list them off. But here, I can't list off the values because there are an infinite number of points that make up this line. Okay, I know we draw a nice smooth line, but it's made up of infinite number of points. So you can have points with an infinite number of different x values. So that's why we say x is an element of real numbers. So why do we write x as element of numbers as opposed to x as an element of integers? Well, I guess we can say there's a lot of things you can say, but how about we say the point, let's make a counter argument, the point root 2,
top search result.
Sorry, my phone talks to myself. The point root 2, so if x was root 2, it would be 2 root 2 minus 5, okay? We'll talk about radicals more often and later on in the course, but 2 root 2 minus 5 is the point. So you see how root 2 is not an integer. It's irrational number. So since this point is on my line, we should say, this is a very strong argument that you should say x is an element of real numbers. It doesn't have to be integer. Okay, so if you said x has to be an integer, you are not looking at this, you're not looking at the entire line. Okay, now since we want to talk about the domain of what I've drawn, okay, then you have to say x is an element of real numbers. Anyway, the point is on y equals 2x minus 5. I mean, what you could have also said is just look at the graph, okay? Look at the graph and it's clear that you cannot write x as an element of integers, because if it was, you would have there'd be no yeah, you'll be missing a lot of points here. Okay, so that might have been confusing because there were no restrictions on x and no restrictions on y. Now, for this problem, hoping you can see the restriction. So let's graph it first. So it's in vertex form. So 1, 3, plot the vertex. We could talk about lots of different things about graphing, but I'm just going to do the step pattern. Okay, so this parabola goes left and right forever. So hopefully you can say that there are no restrictions on the values of x. X can be anything you want. But y, there are certainly restrictions for y. If you look at the graph of this parabola, y can only be values that are less than or equal to 3. Okay, for example, like is there a point on this parabola with a y value of 4? No, because the vertex is the maximum point, right? So the largest possible value for y is going to be 3, and all the other points have a value for y that's less than 3. So, are there any restrictions? Yes. Y is less than or equal to 3. So if that's the case, we're going to add that for our range. When we state the range, we're going to include that restriction. So for domain, no problem. The set of all x such that x is an element of real numbers. But for range, it's the set of all y such that y must be less than or equal to 3 and y is a real number. Y is an element of real numbers. The textbook switches it around, but there are lots of different ways to state domain and range, but you just have to include the fact that it's a real number and the restriction on y and x if it does exist, if there are any. Okay. So now let's state the domain and range for these 5 relations. Now, you have to be careful though. It would be best, because I'm just giving you an equation, if you want, you can give yourself a sketch, okay? So this y equals x plus 1, I know this is a line, okay? It's a line with a y-intercept of 1 and a slope of 1. You can graph it out for yourself, but I know if it's a line, the domain and range will be all real numbers. Please no restrictions, I'm working with a line. Now if it's a horizontal line and a vertical line, different story. But this has a slope of 1, so it's an oblique line, so yeah, domain and range is all real numbers. No restrictions. But just in case, I'll do a quick sketch for yourself, or for you. Something like that. Slope of 1, y-intercept of 1. All right, parabola here. So I know, because it's a parabola, the domain is all real numbers. But I also know that the range is not all real numbers, because this is a parabola that opens up. I can tell that the optimal value is 1, but you know, I'm gonna give you a picture anyways. So now that I have the graph in front of me, it's apparent, okay, it's obvious that the y values have to be greater than or equal to 1. Okay, I'm really hoping that you can agree that if you have the graph, okay, of the relation or the function, it's very helpful to state your domain and range, because yeah, you can see what the possible values of x are. You can see what the possible values for y are. Okay, x squared plus y squared is 36. Okay, so for this one you remember, we have a circle, and everyone knows I'm horrible at drawing circles, but alright, that would do. Okay, so more importantly, what's a domain and range? Okay, it's a set of all x such that x, so if you look at the circle, the values of x can be any number from -6 or 6, or -6 to 6, sorry. It's any value of x, or the possible values of x are any value from -6 to 6, of course, including those values, right? Because like the x-intercept here is -6, and the x-intercept here is 6, so we're talking about any value from -6 to 6. Now, how do you write that down though? So a lot of students have trouble with this, and all I have to say is you do the lower limit of your interval. So x has to be greater than or equal to -6, but at the same time, it's also less than or equal to 6. So that's how you say it's between. It's greater than or equal to the lower limit of your interval, and it's less than the upper limit of your interval. Okay, in this case, less than or equal to the upper limit. So y is exactly the same. It's greater than or equal to -6, but less than or equal to 6 at the same time. So if that's the case, that means it's any number from -6 to 6. Okay, so y equals 1 over x. Now, unfortunately, this one, you don't know how to graph this. You don't know how to graph this. But what you can do is study the equation. So 1 over x, I'm hoping you can say that the domain, okay, x can't be 0. X can be any other real number, but it can't be 0 because 1 over 0 is undefined, like we said in grade 9. Okay, now what about the range? If you study the equation enough, you'll see that the range cannot be 0. Okay, because 1 divided by any number can yield any number you want except for 0. So hopefully you can see that this question was a little harder because you basically have to find the domain and range just by studying the equation. Now, if you had the graph of y equals 1 over x, that would have been much easier. Okay, so since you don't know how to graph this, I'm going to give you the graph, and you'll see that the domain and range matches up exactly. But good news is that we will be graphing 1 over x quite a few times later on, okay, in the second chapter. So this graph, y equals 1 over x, actually has what's called a horizontal asymptote and a vertical asymptote, which we'll talk about later on when we study this graph more in depth. But yeah, that's basically the graph of 1 over x. And hopefully, now that you see the graph of y equals 1 over x, you'll agree that x can't be 0 and y can't be 0. So for questions like this, we're probably going to give you the equation, okay? Because it's unfair to make you study. Well, you can study the equation, but we just don't want you to miss something, okay? But I can really hide the graph and say the exact same. I can look at the equation and hopefully you can agree that x can be any real number except for 0. And looking at 1 over x, okay, looking at all the possible values you can make with 1 over x, you'll also agree that y can't be 0. But it's much easier if you do have a graph in front of yourself. All right, same thing. This one, unfortunately, you don't know how to graph, so what you have to do is study the equation. But I'm going to give you the graph. Actually, before I give it to you, let's just see. So x minus 1. Whatever x value you choose to sub into this equation, we have to make the expression x minus 1 greater than or equal to 0. So if you think about that, okay, if you think about that, x has to be greater than or equal to 1, okay, because you want the expression x minus 1 to be greater than or equal to 0, and if that's the case, then x has to be greater than or equal to 1, because I can't square root a negative value. If I want y to be a real number, then I don't want to square root a negative value. All right, and what about the y values? What about the range? Okay, so the numbers you're going to get from this equation, it's going to spit out numbers. Hopefully you can see that this radical, okay, it's going to give me numbers that are greater than or equal to 0. So greater than or equal to 0 plus 3 means y, at the very least, it's going to be equal to 3. And that'll be numbers greater than or equal to 3. Okay, so this radical is going to spit out numbers. I don't know what x is, but it's going to spit out numbers that are greater than or equal to 0. And if you add 3 on top, that means y has to be greater than or equal to 3. You know what? Let's give ourselves a graph. So how does the graph look? I'm hoping I'm really trying to push the point that if you have the graph, it's a lot easier to state the domain and range. And that's what the homework we're going to practice. Like the homework, I'm going to give you the graph, okay? And this one, you're going to be graphing this later on when we do transformations, just like the 1 over x. So how does the graph look? It looks something like that, okay? So x is based on the graph. You can clearly see that the values of x can be greater than or equal to 1, and the values of y can be greater than or equal to 3. So we started off with reviewing number sets, but we're mostly working with real numbers. If I'm giving you an equation, try your best to give yourself a graph. If you can't give yourself the graph, then really study the equation and look at the possible value. Like, what can you sub in? What can you sub in for x? Okay, are there any problems when you sub in? Like, am I going to square root a negative value? Am I going to be dividing by 0? Okay, so because those questions will help you find the domain. And as for the range, you really just have to look at the possible values you can get from the different values of x that you sub into the equation. So that part's a little trickier. I would argue that stating the domain is easier than stating the range. So find the possible values of x first, and then you can see what values of y you can get from those possible values of x. But yeah, give yourself the graph. All right, so there's domain and range.